Hi, this is Scott from KIG. It's May 15th, 2017, and we're going to do a runoff test today for this 7.5 horsepower 230 volt cold shot chiller set up for a brewery for our customer out in Nevada, I believe. This unit is a 2012. Look at that serial number. It's the second to last two numbers there, that 12-1, I believe that's the first week of 2012, but the 12 is a 2012 unit. It's an ACWC 090, 1.5 horsepower, 230 volt, 208/230 volt three-phase power. We've been running this for a week or two, and we're just going to do a couple videos here, running it down to temperature. We got a 50% glycol solution in the unit right now. I'll talk about a couple things after I power up the unit and get it running. We do have all the covers and side covers, but the way this cold shot chiller works is our condenser is here, so there's no side covers that can be off that would inhibit or prevent appropriate flow through the condenser. So for our tests, we usually leave the side covers off just so we can point out a few things. When you first power up the unit at your main disconnect there on the top of the chiller, on the top of the chiller here you have that voltage monitor, that voltage regulator. It'll go into like a 5-minute delay countdown before it actually starts everything up. We've already done that by having power to the unit. So in this mode here, you basically have a selector switch which is off, pump only, and cooling cycle. We're just going to turn on the pump only. Now when you first get power to the unit and after it goes through that counting time down on the voltage monitor up here, what you want to do is with the helper, you want to get behind, you want to confirm the pump rotation. The compressor rotation is very important and the pump rotation too, they're synchronized. Looking in the back of the chiller, you want to go clockwise while looking from the back. Now if you get a flashlight and look through there while somebody just bumps that switch, going from off to pump, you'll be able to see if you got the right rotation. If you don't have the right rotation, then you should change. Kind of on a tall skid here. Then you should change any of your two main incoming power wires here, the main contactor. You'll probably want to bring in your incoming power here, like we did, and snake it up to the bottom of the unit here. Then put your appropriate covers on. So we've preheated the tank up to a little bit above 80. Just going to turn it over to cooling mode. It actually turned on right away, and the compressor quiets down after a second or two. You don't have to worry about SMT, which is smart test. When you change the set point, you just have to simply press function, set point 1, or set point, and just press the down key. And for brewery chillers, most people want to set it at 28 Fahrenheit, give or take. And we've gone through this, done a couple things. We'll talk about those in a minute. So we're chilling right now, and what you just heard is the fan kick on. So this unit has, for whether you need it or not, for colder running environments, it has a combination of fan switching and fan speed control in conjunction with this hot gas bypass valve. So when the compressor is on, which it is right now, the fan isn't always necessarily going to be running. That is normal. So it's balancing depending on what the pressures are. This unit has a low pressure switch which is rated for lower glycol temperatures. Now, with the cold shot chiller, your heat exchanger is actually submerged in the tank down here. Kind of tough to see, but it's there. And what we do For a brewery application, we actually modify the piping of the unit. What Cold Shot calls it is they kind of call it a double return. So we actually, here at KIG, we actually punch a hole in the stainless steel tank, and we have this new line that comes out here. Okay, and this is your return. That's a zero pressure return. So there's no pressure required coming back to the unit, which is what you want for a brewery application. So what we have is the pump draws off your tank here, okay, and comes up here. This line here, the bottom one, this comes out to your process. That comes out to your supply for your brewery tanks. We have a second line here with a globe valve that recycles back to the tank, and that goes into the inlet side of the brazed plate heat exchanger inside the tank there. What we have here, that's a flow switch to sense flow. So with this valve here, you're going to balance the output of the pump. Essentially, it's almost teeing off here. Part of your flow is going out to your process. The other part of the flow is going directly back into the heat exchanger. Now the reason for that is a brazed plate heat exchanger requires a certain amount of pressure and flow to behave correctly. By piping it this way, okay, we avoid the need to have high pressure in your return lines on your return side of your glycol brewery piping. This is a R410A refrigerant, by the way. You can see we're already down to about 53 Fahrenheit. This unit here will probably go a couple degrees below set point stop, and I'll probably wait till you're a couple degrees above set point before it comes back on again. So this cap here, that stays on for your application. That's the lower one, that's your out to process. And we do have the stainless lid for the tank. The compressor does have a crankcase heater. When you first put power to the chiller, or as soon as you put power to the chiller, that's always on. We recommend at least 12 hours. I think the manual says 24 hours of that crankcase heater on to make sure the refrigerant's not too cold before you first start it up. Here's another one. This one's going to a same modification. That's going to a brewery up in northern Massachusetts here. Then we have a little 2-ton going to another brewery, and then we have some other chillers here. This is the back section of our 13,000 square foot facility. Our bigger chillers are in the front of the factory. So to achieve the low ambient capability I mentioned earlier, it's a combination of LA, that stands for low ambient thermostat. You shouldn't have to change that. Fan speed control, which I think is, in this case here, the P266, Johnson Controls P266 module. The only other thing worth mentioning is the control transformer. It's got a little dust on it. We'll blow that off before we ship it. The control transformer, you have the option of 220, 240 volt or 200, 208 volt for incoming power. It leaves here wired for the 220, 208, 240 volt. They can make a slight difference sometimes if you have lower voltage in your plant, meaning 200 or 208, in which case you just want to change two of the two wires on the primary side of that transformer. warmer. The unit leads intentionally with a little jumper there. You see that red jumper? That's actually an option for if you want to set up for remote on-off start. So depending how fast we're chilling, we can. Well, now we'll come back to video number 2 in a second here.